All right, young scholars. This week we are going to cover inheritance and polymorphism. In essence, inheritance means creating new classes based on existing classes. You'll have a superclass that can send information down to subclasses. Think of the way you inherit genes. You inherit from your mother and father. They would be the superclass, and you would be the subclass. In this example, the geometric object is the superclass, and the circle and rectangle would be subclasses. They would be able to take all of the methods and information from that generic geometric object and use them themselves. Unfortunately, though, superclasses constructors cannot be inherited. They're invoked in some kind of way using the super keyword. If the keyword super is not explicitly used, the superclass's no argument constructor is automatically invoked. And this is exactly how that would work. Public A would be your superclass. It would be written exactly the same, obviously with less code on the left-hand side. If you included an argument double D, that would be passed through to the subclass. However, if there is no arguments, it is passed as a no argument. So the keyword super refers to the superclass of the class in which super appears. This keyword can be used in two different ways: to call a superclass constructor or to call a superclass method. As you saw in the geometric object example, you may pass drawing a shape to circle and rectangle as an example. However, there is a caution. You must use the keyword super to call the superclass constructor. Invoking a superclass constructor's name in a subclass causes a syntax error. In other words, if you're calling on it without using that super designation before it, it's not going to compile. It's going to provide you with a syntax error. So there's something called constructor chaining, and that's an instance of a class invoking all of the superclass's constructors. You may only need to invoke one. You may need to invoke multiple. In this example, we're creating a new faculty member and then passing it as a no argument constructor. But earlier we created an extension of employee, and now we're creating a new class employee that extends person. Then we extend employee using the argument S, string S. Then we also invoke a new version of person, which we created earlier. Employee extends person. So you notice in the next 9 slides here where we're tracing execution that first we start from the main method, our public static void main with string arguments. Then we invoke the new faculty constructor in order to create a new class, faculty. We then invoke an employee no argument constructor. Notice nothing in the parentheses, no argument. Which then allows us to invoke the employee string constructor. We're now putting a string inside that employee constructor using string S. Then we invoke the person constructor. Notice again, there's no arguments in it, nothing in the parentheses. Then we execute our print line to display persons no arg constructor is invoked. We also invoke the print line within our employee class and within our employee extends person class and within our faculty class. So you notice there's 1, 2, 3, 4 different instances where we're printing out information. Find the errors in this program. Since we're extending fruit as a no argument constructor, the parentheses must be empty. String name should not be there. The error is that the constructor fruit in class fruit cannot be applied to given types. So we can't have string name, we can't have string S, etc. When you're defining a subclass, it inherits from the superclass. You can also add new properties, add new methods, and override the methods of the superclass. Think of the traits you get from both of your parents. One of them might overwrite the other. One parent might have blue eyes, one parent might have brown eyes, and you ended up with brown eyes. In this instance, we're calling the superclass print circle. In this instance, we're also inheriting a radius and the date created. Super.date created and our variable radius. So whatever they have been set within this superclass is how they would be used going forward. As you saw with numbers, we can also override methods in the superclass. Overriding is done when a method needs to be used in a different way in the subclass. So in this example, we're overriding the toString method to now replace it with radius is and whatever the radius variable is. However, an instance method can be overwritten only if it's accessible. As we saw, public versus private. A private method cannot be overwritten. In other words, private methods are inaccessible as we described last week. You would have to set them as public. And just like an instance method, a static method can be inherited. However, a static method cannot be overwritten. If a static method defined in the superclass is redefined in a subclass, the method defined in the subclass is hidden. Just like static, similar to creating websites. A static website may never change. A dynamic website will change. So in this example, we're giving more of a clear understanding of overriding versus overloading. You'll notice in this example, we've already established a double I within class B. Class A is now overriding that. So whatever we set in class B of double I will now be overridden within class A that extends class B. Just like we saw with the numbers. If I equals 5 and G equals 7, if we set I equal to G, now I also equals 7. Whereas with overloading, you'll see this example. We have double I again in class B. However, we've now changed it to int I in class A. Overloading means a complete change that may change the entirety of that variable method constructor. The reason we went over objects last week is because objects can be used in a variety of ways, just like you saw last week. Drawing, creating different object interpretations, and how you can use them going forward. One of them we've used with the arrays is the toString method object. In this instance, we're creating a new object called loan, and we're setting it as a string. It's going to display something like loan at and a random number representing the object. Because you would assume a loan would be some kind of integer currency. With respect to polymorphism, it means that a variable of a supertype can refer to a subtype object. In essence, it means that one of these objects can take on many forms. So a circle can be a subtype of geometric object, and geometric object is a supertype of circle. As you saw before, geometric object was also the superclass for rectangle. It could be for triangle, etc. There's something you could do within polymorphism called dynamic binding. Within dynamic binding, the function of the method is not decided at compile. It allows us to ignore the differences in type. So you may have 8 different instances, and it runs through them before it decides what to do. Method matches versus binding. Matching a method signature and binding a method implementation are two issues. The compiler finds a matching method according to parameter type, number of parameters, and order of the parameters that compilation. A method may be implemented in several subclasses. However, when it's compiled, the interpreter or the compiler decides on which of the method to execute. So here's an example. We're creating a public class, public morphism demo. We're creating a method that creates new graduate student, new person, new object. So new graduate student, new person, new object, all are pretty much the same. Then we're going to print out our new object to string. In this instance, if it's a person, or a student rather, we'll return student. If it's a person, we'll return person. So it's a little convoluted, but you can set different methods as different objects, even though they might be the same. You know, a student and a graduate student, a student and a person, individuals might classify under all of those different possibilities. When you're casting an object, you're using it to convert an object of one class type to another within an inheritance hierarchy. So in this instance, we're creating a new student M, but we can create an object O using that new student object type, which is called implicit casting. So why might you want to use casting? Suppose you want to assign the object reference O to a variable of the student type using the following statement. You get a compile error. The student object is always an instance of object, but an object is not necessarily an instance of student. Even though you can see that O is really a student object, The compiler doesn't understand that. It doesn't know that. So you have to use explicit casting. So student B equals student as the parameter O, which now changes O to a student object. And here's another example of how you would cast from a superclass to a subclass. So fruit would be our superclass in both of these instances, and apple and orange are both subclasses because an apple and orange can be a fruit, but a fruit isn't necessarily an apple or an orange. You can also use the instance of operator, just like we saw previously with this. So we're creating here a myObjects instance of circle. So we're casting the myObject now as a circle object. There's also instance of pattern matching, which compares different types, string to string, double to double, etc. So in this example, we're creating another instance of a circle object to get its area, get its diameter, and then creating an instance of a rectangle object, getting its area. However, the basic object is to consider the fruit as a superclass of apple and orange. Like I mentioned earlier, an apple is a fruit, so you can always assume that the apple is the subclass, the fruit is the superclass. However, a fruit is not necessarily an apple, so you would have to use explicit casting to assign an instance of fruit to the variable of apple. You've seen the equals method previously, hopefully within programming 1. In this example, if the object is a circle, then the radius returned else. Nothing is returned. So if our object is in fact a circle, we will return the radius of that circle. Else, nothing. We just get a false. Nothing happens. You would use an equals if you were just checking to see if an int or double matches. Does 5 equal 11? You use the double equals for more advanced comparisons. It's stronger than the equals method. It checks whether the two reference variables refer to the same object. There is also an array list class. You'll remember that the array's size is the elements / index one set. There is also the possibility of a generic type. It will not store ints, doubles, etc. Primarily, it's just going to be set as strings. You'll notice with an array list, we'll use a less than and greater than sign around instead of the more common brackets that we've seen when we create just a regular array. So often we used arrays set up using a for loop, our own input, or user input. An array list can be done the same way using list.add, adding the string London in this city example, or you could do index comma London to add it to the end of the array list. Generally, you could not add with just an array unless you inputted it yourself through the user or a for loop. So you've now placed the strings that have been provided in order to create an array list. red, green, blue, were created in this array here. And now they can be returned as a list using the array list. Array lists are sorted so they are in ascending order. That means from smallest to largest. So your first element is usually your min, and your last element is usually your max. You can also shuffle an array list. However, shuffling is closer to a randomization of those pieces of your array rather than sorting them. Within stacking, think of it as a Pringles can. The Pringles are all stacked one on top of each other. Of course, assuming they're not broken and some of the pieces fall off to the side. You could stack pieces of an array one on top of each other. A protected modifier can be applied on data and methods in a class. A protected data or a protected method in a public class can be accessed by any class in the same package or its subclasses, even if the subclasses may be in a different package. Here's a summary of how you could access different modifiers. Generally, only set something as protected if a different package or class does not necessarily need to use it. Here's an example we showed of visibility modifiers. We can access 0.x, it's public. We can access 0.y, it's protected. We can access 0.z, it's just labeled as int, so by default it's public. We cannot, however, access 0.u, it's been set as private. A subclass cannot weaken the access visibility, which this means simply is that you can't drop from public to protected, protected to private, etc. The modifiers are used on classes and class members, such as data and methods, except that the final modifier can also be used on local variables in a method. A final local variable is a constant inside just the specific method. And as a reminder, a final is unchanging. So here we have final class.math. That class cannot be changed. Final variable is constant, such as final static double pi. It cannot be overwritten by any subclass, which in this specific instance, there's no reason to overwrite pi. Pi is always going to be its constant. So later this week on Thursday, we will cover some programming exercises related to inheritance and polymorphism that will give you a further clear understanding of how this all works.